7-1. Zero and negative exponents. Objective: to simplify expressions involving zero and negative exponents. Copy and complete the table. Make a conjecture about how the value of an exponential expression, an expression containing an exponent, changes when you decrease the exponent by 1. What do you think the value of 5 negative 2 is? Explain your reasoning. So here we have 10 to the 4th. So we have 10 times 10 times 10 times 10. 1, 2, 3, 4. I know I'm going to end up with 4 zeros. But if I go down to 10 to the 3rd, I'm going to have 10 times 10 times 10, which is 1,000. And then 2 tens multiplied to itself is 100. 1 10, that's it. So I only have 1 10. But then if we look at it, what happens when I have 0, 10 to the 0? So now here's where we start changing. We're moving into algebra here. And so if we look at this, we divided by 10 to get here, divided by 10 to get here, divided by 10 to get here. So if we divide by 10, what do we get? 10 divided by 10 is 1. Well, if I take 1 and I divide by 10, so now I'm at negative 1. So I'm going to divide by 10. But to change to the very last one, I'm dividing by 2 tens. So I have 1 to the hundredths. Okay, it was easier to do the tens before the 2's because you could see that we kept dividing by 10 as we went backwards. So 2 to the 4th is 16. If we divide by 2, it's 8. So if we look at 2 to the 3rd power, 2 times 2 times 2 is 8. So that makes sense that when we are decreasing our exponent, we just had to divide by 2. 2 times 2 is 4. So these ones we could see pretty easy. And then we only have 1, 2, so that makes sense that we are only at 2. But now we have the 2 to the 0 power. And if we look at our pattern here, we keep dividing by 2, dividing by 2. So if I divide by 2, I end up at 1. I ended up in the exact same place as over here. So it didn't matter 10 to the 0 or 2 to the 0. We ended up at 1. So what is going to happen here? So if I divide by 2, we have a negative 1 exponent. So it says we're going to divide by 1 2. Here we're going to divide by 2 2's. So we can see our exponent is still the exact same thing of here's only 1 2 and here we have 2 times 2, but the negative is pushing it to the other side of the fraction bar line, so we are actually dividing. The patterns you found in the Solve It illustrate the definitions of zero and negative exponents. Essential understanding: you can extend the idea of exponents to include zero and negative exponents. Consider 3 cubed, 3 squared, 3 to the 1st. Decreasing the exponents by 1 is the same as dividing by 3. If you continue the pattern, 3 to the 0 equals 1, and 3 to the negative 1 is equal to 1/3. So you can see, even though it was 10, 2, but now it's a 3 to the 0 power, it is equal to 1. Okay, so now we're back to our properties, where we were taking notes in an earlier chapter. Zero and negative exponents. We have another property. This works every single time. Zero as an exponent for every non-zero number, a to the 0 equals 1. So this works for every number as long as it's a non-zero number. It can't be 0 there. So 4 to the 0 equals 1, negative 3 to the 0 equals 1, 5 and 1400ths to the 0 power equals 1. Negative exponents. For every non-zero number a and integer n, it's equal to 1 over a to the n. So the negative is pushing you to the other side of the fraction bar line. So you need to make sure that you remember that what this negative means. A negative exponent pushes you to the other side of the fraction bar line. So we have an example here of 7 to the negative third. So to get rid of the negative, we have to go to the other side of the fraction bar line. So we have 1 divided by 7/3. Negative 5 to the negative 2. So again, we get pushed to the other side of the fraction bar line, and we have negative 5 squared. When you evaluate an exponential expression, you can simplify the expression before substituting values for the variables. Problem 3, evaluating an exponential expression. What is the value of 3s cubed t to the negative 2 power for s is equal to t and t is equal to negative 3? So remember, you need to separate it right here so you can see what your variables, the value of your variables, and then you have the problem. Okay, so here we have it. Simplify first. So we have 3s cubed. We push our t to the other side of the fraction bar line. Now we can see we have a 2 cubed, negative 3 squared. And so 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So here's another way of writing 8. 8 times 3 is 24. There's our 24. Negative 3 times negative 3 is a positive 9. And then 24 divided by 9, 2, remainder 2. Sorry, it's not a remainder 2. It is a remainder 6. And they simplified it down to 2/3. So there's one more step inside here. So we have 2 remainder 6 divided by 9, and we simplify it down to 2/3. So a lot of the simple elementary math isn't done for you in the book. You just got to know what happened between those two. So you remember to do that when you get to a problem. A second way you can do it is you can do your substitution first. So we look inside here, we put our numbers in, and then we push our negative 3 to the other side of the fraction bar line, and we still end up in the same place. Problem 4, using an exponential expression. Population growth. A population of a marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate and express for h is equal to 0 and h is equal to negative 3. What does each value of the expression represent in the situation? We know that 1,000 times 2 to the power of h models the population. We need values of the expression for when the hour is 0 and the hour is negative 3. So we substitute each value into h into the expression and simplify. So here we have our equation, and we take out the h, put in our 0, which is 1. So of course at 0 hour we have 1,000. That's our starting point. The value of expression for h equals 0 is 1,000. There are 1,000 bacteria at the time the scientists measured the population. So at 0 hour. This is substituting in negative 3. So we push the 2 to the other side of the fraction bar line, and 2 times 2 is 4, times 2 is 8. So here's our 1/8. And so when we multiply this, we have 1,000 times 1 divided by 8 is 125. The value of the expression for the hour at -3 is 125. There were 125 bacteria 3 hours before the scientists measured the population. Okay, it says simplify each expression. So number 9, it says 3 to the -2, the power of the -2. Okay, so I know that is equal to 1 over 3 squared, and 3 times 3 is 9, so there's my answer. So I have a -5, but the negative is not a part of the exponent. So the negative is out here, so 1 over 5 squared, 1 over 5 times 5 is 25. So, but it really doesn't matter on here, because the negative, whether it's out in front, up here in the numerator, or down in the denominator, those three are the exact same thing anyway. Okay, when I have variables in there, we know that anything to the 0 power, it's the same thing as 4 times a times 1. 4a times 1 is 4a. Here in number 25, we have a negative exponent, so that pushes this to the other side. 3 times 3 is 9, and I already have an n down there. We take a look here. I don't have anything without a negative exponent, so there's nothing in the numerator. C to the 5th, D to the 7th. Number 33. 6 doesn't have an exponent, so that's going to stay in my numerator. A is a negative exponent. C to the 3 has that negative to push it to the other side. And D has a 0, so that one's just gone. So there's my answer, 6 over AC cubed.